Hello, good day everyone. So welcome back to my YouTube channel, and this is Catholic and Vlogs. And today we'll be talking about discrete random variables, and this is mathematics in the modern world. So, discrete random variables. Random variables are expressed as capital letters, usually from the end of the alphabet. For example, X, Y, Z. And the value they can take on is represented by lowercase letters, for example, X, Y, Z, respectively, here. And the random variables, okay, this one, and the random variables is categorized into two, discrete and continuous random variables. Discrete random variables generally deal with the number or size or outcomes were able to be counted. So take note, it is counted. And next one is continuous random variables. Generally deal with quantities which can be measured. Okay, that can be measured, such as mass, height, or time. Okay, take note, there are two categories of random variable. The first one is discrete and the second one is continuous. When I talk about discrete random variables, generally deal with the number of size and are able to be counted. A discrete random probability distribution exists only if the following characteristics are satisfied: that each probability lies on the restricted between 0 to 1. So take note, only the probability, each probabilities lies in restricted interval 0 to 1. And the probabilities of a particular experiment sum to 1, that is, the summation of probabilities is equal to 1. If these two characteristics are not satisfied, so therefore there is no discrete probability distribution. So we have to think that these are the characteristics that we need to be this should be met in order to be categorized as discrete probability distribution. All right, so let us have first this one example. Which of the following represent discrete random variables? The first one is the number of goals scored at the football. So we could say that this one is discrete. Why? Because uh, goals can be counted. So therefore, if that can be counted, so this is a discrete random variables. The next one is the height of students. So this one is discrete. And the next one is the height of the students in maths method class. So therefore, this one particularly is a continuous because height must be measured. Okay, height must be measured, so therefore this is continuous. So therefore this is not a discrete. Next is shoe sizes. Shoe sizes is this particular is discrete. Okay, and the next one is the number of girls in five child family. So therefore countable or can be counted. So therefore this is discrete. And the last one is the time taken to run a distance of 10 kilometers in a minute. In minutes. So therefore this is continuous because time must be measured. Alright, so these are the particular how to determine whether it's one is discrete or continuous. But in this case, we are going to check which of the following represent discrete random variables. Alright, so next is let example number 2, let x represent the number of tails obtained in 3 tosses. Draw up a table which displays the values of discrete random variable, can assume, and the corresponding probabilities. So let us represent this one by the using of the tree diagram. Okay, if this is our coin, so the first one is when it toes first coin, so this is head and tail. And the second toes, we have here head and tail, and this one also could be paired with head or tail. And the last one, the third toes, head or tail. So this one is head or tail. Next is head or tail, and the next one is head or tail. So the question here is, let x represent the number of tails obtained in three toes. So the number of tails obtained in three toes. So draw up a table. So we need to draw up a table. So first we have to identify this one in three toes. We have here head, head, and this one is head, head, tail, and this one is head, tail, head, and this one is head, tail, and tail. And this one is tail, head, head, and tail, head, head, tail. And this one is tail, tail, head, and the last one is tail, tail, tail. What we're going to do is we're going to make a table. So if we're going to make a table here, okay, let us have a table. The first one is we need to find, okay, so the number of tails, let us represent the number of tails, will represent as our x, and the probability of obtaining. So the probability of revision of x. So let us assume that the first one is the number of tails is 0. Okay, how many, what is the probability when you get 0 tail? So let us have 0 tail. So 1. Okay, 0 tail. So this one ay tail, meron, 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 meron. So therefore, the probability is 1, 2, 3, 4, 5, 6, 7, 8. So therefore, this is 1 over 8. Okay. And the next one is probability that obtaining, because the maximum tail should be acquired is 1 out 3, and the lesser the last one is 0. So therefore 0 to 3 expected the number of tails. So therefore we could have this 1 as the number of tails. So how many number that has how many results that has one tail? So 1, 2, 3. Okay, so therefore this is one tail, so 3 over 8. And the next one is 2. 2 tails, because we're focusing on the number of tails obtained. So 2 tails, 1, okay, 2, and 3. So therefore, still 3 over 8. And 3 tails, so only the 1. So therefore, this is 1 over 8. So we have completed already the table that displays the values of discrete random variable that can assume our corresponding probabilities when we let x represent the number of tails obtained in three toes. Okay, so this is an example. Next, let's proceed now. Which of the following represent the discrete probability distribution? We have to take note of these two characteristics. The first one is that each probability should lie in a restricted 0 to 1 and 0 to 1, and the probabilities of particular experiment should sum up to 1. So let us check here in A. Let us check whether the probabilities lie from 0 to 1. So 0 0.2, 0 0.5, 0 0.2, 0 0.1, it lies between 0 to 1. So therefore, this is all probabilities lie between 0 and 1. Okay. Letter B, it should be the probabilities of a particular experiment sum up to 1. If we're going to add this one, 0 0.2 plus 0 0.5 plus 0 0.2 plus 0 0.1, the result is 1. So therefore, check and check So therefore, the two categories or the two characteristics rather are being met here. So therefore, we could say that this is a discrete probability distribution. Yes, this is discrete probability distribution. The next one is this. First is let us check if all probabilities lie between 0 to 1. So therefore 0 0.5, 0 0.3, 0 0.1, 0 0.1, that is checked. So therefore these probabilities lies between 0 to 1. And letter B, the sum of probability should be equal to 1. So 0 0.5 plus 0 0.3 plus 0 0.1 plus 0 0.1. So we have here 1. So therefore check. So therefore this is another example of discrete probability distribution. The next one is this. So we have here x is negative. The probability is negative 0 0.2, 0 0.3. Okay. Negative 0 0.2, 0 0.1, 0 0.3, 0. Okay. This one. So let us check. First, each probability lies on a restricted. The answer is no because their probability is negative 0.2. It does not lie between 0 and 1. So therefore, we could say that this negative value x na daan, therefore it will not represent a discrete probability distribution. Why? Because there is a negative value of the probability. So it does not represent discrete probability distribution. So therefore this is x. Okay? Even though it sum up to 1, but still the first condition is not met here. Okay, letter D. So, okay, this is not. So letter D, let's check. If this is, the first is all probabilities lies between 0 to 1, 0 0.2, 0 0.1, 0 0.3, 0 check. But let us check for the next characteristic if it will meet the second characteristic. So 0 0.2 plus 0 0.1 plus 0 0.3 plus 0 0.3. The result of this one is 0 0.9. So it does not met the second one that it should be sum up to 1. So that does not met. So therefore, this would not represent a discrete probability distribution. Okay, so I hope you understood all about representing a discrete probability distribution. The first characteristic should be each probability lies in a restricted interval between 0 to 1, or it should be in a closed interval 0 to 1 because 0 is included and 1 is included. And B, the probabilities of particular experiment sum up to 1. So if you're going to add the probabilities, it should sum up to 1. To make it, if these characteristics are met, so therefore this would represent the discrete probability distribution. Okay, the next one is find the value of k for each of the following discrete probability distribution. Since we know already the idea what is the discrete probability distribution, so we're going to solve for this one. So the category or the characteristic of discrete that it should sum up to 1. So we have here 0 0.2 plus k plus 0 0.2 plus 0 0.3 plus 0 0.1 to make it a discrete probability distribution, so this is equal to 1. So there is 0.2, 0.2, 0.3, and this 0.1 is 0 0.8 plus k is equal to 1. So k is equal to 1 minus 0 0.8, so k is equal to 0 0.2. So therefore, the value of this k is 0 0.2 to make it a discrete probability distribution. So the value for k is 0.2. Let us have example B. So we're going to find the value for k of this distribution. So since it is understood already that the summation of this probability should sum up to 1, so we will equate this one into 1. So 5k plus 6k plus 4k plus 3k plus 2k is equal to 1. So if we're going to sum this one, 5k, 6k, 4k, 3k, 2k is equal to 20k is equal to 1. So therefore, the value for our k is 1 over 20. Okay, so the value for our k here, to make it a discrete random variable, is 1 over 20. Okay, let us have this one. Show that the probability function 1 over 42 5x plus 3, where x is equal to 0 to 3, is a probability function. So let us have first, okay, the category. Okay, first is it, the the probability should lie between 0 to 1, and the second one is the sum of the probability should be equal to 1. So if we're going to make a table here, okay, if this is our x, p, okay, so starting with 0, 1, 2, and 3. Okay, so we need to substitute the value for this one to get the probability functions here. So when x is 0, so let us have first, when x is 0, if we're going to substitute here, 1 over 42 times 5 times 0 plus 3. So therefore, this is 1 over 42 times 3. Okay, so therefore this is 3 over 42 is equal to 1 over 14. So therefore, the answer for this one is 1 over 14. When x is equal to 1, so 1 over 42, 5 times 1 plus 3. So therefore, this is 1 over 42 times 8. So this one, 8 over 42. If we're going to simplify, this is 4 over 21. Okay, 4 over 21. When x is equal to 2, so what is the value? The value is when x is equal to 2. So 1 over 42 times 5 times 2 plus 3. So therefore this is 10, 13 over 42. Okay, 13 over 42. Next, when x is equal to 3, so 1 over 42 times 5 times 3 plus 3. So this is 1 over 42. This is 18. So therefore, this is 18 over 42. That is equal to 3 over 7. So this is 3 over 7. So the first characteristic, it should be the probability is between 0 to 1, check for first characteristic. And the second characteristic should be, it should sum up to 1. If we're going to compute this one, 1 over 14, 4 plus all the probabilities, we're going to add all the probabilities. So it met because it met the requirement because it is equal to 1. So therefore, this one is a probability function. Okay, because it follows, or it met the two characteristics. Okay, so let's have example number 6. Show the function p of x, 1 over x, 1 over 100, 1 over x squared 6 minus x, where x is 2, 3, 4, 5 is a probability functions. So first we need to have a table here. Okay, the table. So if this is our x, probability distribution is x is equal to x, starting with 2, 3, 4, and 5. If we're going to substitute the value for when x is equal to 2, so 1 over 100, 2 squared, 6 minus 2. Okay, by using this function, so therefore this is 1 over 100 times 4, or rather this is 2 times 4, this is 16 over 100. 16 over 100 we can simplify as 4 over 25. So therefore this is 4 over 25, and when x is equal to 3, so 1 over 100 times 3 squared, 6 minus 3, so this is 9, 1 over 100 times 9 times 9 times 3. So this is 27 over 100. Okay. Next is when we're going to let x is equal to 4. So 1 over 100, this is 4 squared, 6 minus 4. So this is 1 over 100, 16 times 2. This is 32 over 100. So we can simplify as 8 over 25. Okay, there's last one is x is equal to 5. So 1 over 100 times 5 squared, 5 minus 6 minus 5. So this is 25. This is 1, 25 over 100 or 1/4. Okay, so the first test is it should be all probabilities are between or lie between 0 to 1, close interval. So therefore this is check. The characteristic 1 is check or have met. And the next one is we're going to add the probabilities. 4, 25, 27, 100, 8, 25, and 1/4. If we're going to sum that one, that's equal to 1. So therefore, this is check. So we could say that this function is a probability by showing this that this function is a probability function. Okay, try this at home. Which of the following is probability function? And the second one is find the value of k for each of the following discrete probability distributions. So thank you so much for listening. I hope you learned something about discrete random variable or probability distribution. Thank you, and please watch the next videos and comment your suggestions or comments here in our YouTube channel.